Okay, a little bit tricky this one. The x-coordinate of q is 4 more than the x-coordinate of p. Y-coordinate of q is 5 less than the y-coordinate of p. Okay, so I'm going to make up a point for p. I'm going to make p be 0, 0, and I'm going to draw a little picture. If p is 0, 0, this is always x and y, alphabetical order for coordinates. The x-coordinate of q is 4 more than the x-coordinate of p, so we're going to call that 4. And the y-coordinate of q is 5 less than the y-coordinate of p, so that would be -5. We've got to work out the gradient. Two ways to do it. I could draw a picture. I could go p is at 0, 0, that's p. And I could go q is 1, 2, 3, 4 along, and 1, 2, 3, 4, 5 down. It's over here. This is q. If I draw the line connecting it, doesn't have to be accurate, I can see that the gradient of this is always delta y divided by delta x, or change in y divided by change in x. The change in y is -5. The change in x is 4. That's -5 quarters. You can work it out as a decimal. It doesn't matter. The other way you can do it is if you know this formula for gradient, which you should do, you just plug in your numbers. So we can call this one x1, y1, and x2, y2. So we're simply labeling them, and you get -5 minus 4 divided by, I think I've done that wrong. Yes, -5 minus 0, sorry, y1 is 0, divided by x2, which is 4, minus x1, which is 0. And you get -5 divided by 4, or -1.25.